Hello, this is a video on trapezoids. They are quadrilaterals that are non-parallelograms. So quadrilateral four-sided polygon and has all the quadrilateral properties, but it does not have any of the parallelogram properties. So real quick, your definition for a trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. All right, really important. So if you take a look at this picture that I've drawn for you here, you can see the one pair of parallel sides indicated by those arrows there. And that parallel sides is called the bases. All right, the two sides that are parallel are called the bases. All right, the two sides that are not parallel, those are called legs. Okay, so the bases are parallel but are not congruent, because if the bases were also congruent, then you'd have a parallelogram. That's not what we've got here. And then the legs are the non-parallel sides. Okay, so again, all of the characteristics that go with quadrilaterals, like the four angles add up to 360 degrees, four sides, that's true for trapezoids, but we don't have the parallelogram properties that we had for a square or a rectangle or a rhombus. All right, but knowing what we do know, that we do have a pair of parallel sides, we do have some ways that we can solve and figure out and use some characteristics. So I've got this example for you here just to kind of model how we use some of these characteristics. So for instance, because we only have one pair of parallel sides, we can't talk about 120 and x being same side interior angles and being supplementary. That's not going to happen because AD and BC are not parallel. But X and this right angle, angle A and angle D, those are same side interior angles because those lines A, B, and DC, those sides are parallel. So because they're parallel and they share that transversal AD, then these two would be same side interior angles. So we could say that X plus that 90-degree angle is 180 degrees. So we could figure out X by subtracting 90 from both sides, and X would also be a 90-degree angle. So this is like the one situation where same side interior angles are congruent and supplementary at the same time, as if that is a 90-degree angle. All right, similar situation, angle B here with 120 degrees and angle C here with Y, those would be same side interior angles as well. So they would add up to 180. Subtract 120 from both sides to get Y by itself, and that would be 60. So we just found what X and Y are using same side interior angles because we do have that one set of opposite sides that are indeed parallel. All right, now we do get some symmetry when we have this scenario called an isosceles trapezoid. An isosceles trapezoid, similar to an isosceles triangle, it's got two sides congruent. But the sides that are congruent are the non-parallel sides. Very, very, very important. So the legs are what's congruent. So in this case, the legs that are congruent are TP and RA. Those are your congruent legs. So not parallel, but they are the same. And by them being the same, you can see the symmetry that I was talking about. And with that symmetry brings in some more characteristics. Like for instance, the base angles are congruent. That's the angles on either side of the bases. So angle P and angle A would be the same. And up here at the top, angle T and angle R would be the same. Those measures are the same. Now it's still a trapezoid, so same side interior angles for the top and the bottom because of that one set of parallel sides. Those would be supplementary, but these base angles are congruent. And the diagonals, so from the opposite angles connecting, T to A, R to P, those diagonals are congruent. Again, because of the symmetry. Now, they don't bisect each other. They don't cut each other in half. They don't meet at a midpoint, but they are congruent in length in general. So these are some parallelogram properties that show up because of the symmetry of an isosceles trapezoid, but not all of them, because a trapezoid is not a parallelogram. So just take a second. If you need to pause your screen and write down those characteristics, go right ahead. I've got an example that I want to do to model some of the isosceles trapezoid properties. So in this example, ABCD is an isosceles trapezoid, and we're going to find the value of x, and we're going to find the perimeter of that ABCD. Okay, so let's first talk about these angles. Well, remember, base angles in an isosceles trapezoid are congruent. So if you take a look here, these two sides here and here that I'm marking with those slash marks must be my congruent legs. And that means the opposite sides here are the ones that are not congruent. Those are my parallel sides or my bases. Okay, well, the base angles are congruent. So this angle and this angle must be the exact same thing. So even though I've got some information about angle B, it's not congruent to 37, so it's a little bit of a distractor. Now I do know, because it's a trapezoid, angle A and angle B are supplementary because they're same side interior angles, and I can use that to help me solve for X if I wanted to. But knowing that this is an isosceles trapezoid because they gave me that in the information, I could set those two things equal to each other. So 37 is equal to X minus 11. And I'm just going to add 11 to both sides in order to get X by itself. And that's going to give me 48 is equal to X. So again, I could check my work to make sure I did it right by making sure that angle A and angle B add up to 180. And you'll find that that is true. All right, so now I'm trying to find the perimeter. So that's all the sides added together. Well, I've got three of the sides and I just need the fourth side. Well, remember that the legs are congruent. So AB and DC are legs, so they should be the same thing. So I know that if AB is 5, DC should be 5 immediately. And now to find the perimeter, I just add those four sides together. 5 plus 3 plus 5 plus 7. So that's going to give me 5 and 3 is 8, plus 5 more is 13, plus 7 is 20 centimeters. So there's your characteristics for a trapezoid. Lots of practice needed. Good luck. Okay, finishing up with our trapezoids. We do have a special segment in trapezoids called a mid segment, or sometimes you might see it called a median. A mid segment is a line segment that connects the midpoints of the two legs of a trapezoid. So the endpoints of a mid segment are midpoints of the sides that are not parallel in a trapezoid. So I got a list of the characteristics here for you. The endpoints are midpoints. So that's why you've got these congruent marks on here. I'm indicating that A is the midpoint of that left side and B is the midpoint of the right side. All right, that mid segment is parallel to the bases, so you could see the arrows marking all that. The length of AB is actually the average of the two bases. So if you know what the length of the two bases are, you can add them together and divide by 2, and that average, that right there in the middle value, that's what the length of the mid segment is going to be. So right there I gave you a real quick formula for how long AB would be. It would be base 1 plus base 2 divided by 2. So it's the average of the two bases. Okay, so it's the it connects the midpoints of the two legs, and the length of it is the average of the two bases. And again, it's parallel to the two bases. So if you want to kind of see that being modeled with all those characteristics, I've got this example here, and I want to find what X and Y are. Well, if I just focus on X first, then I see that it's X minus 2 represents the length of that mid segment there, because the endpoints are midpoints according to these congruent marks. So that means that X minus 2 is the average, add up the two bases and divide by 2. So then I'm just going to simplify and solve this equation. So X minus 2 is 36 divided by 2. Well, 36 divided by 2 is 18. Now I'm just going to add 2 to both sides. X is equal to 20. So the length of that mid segment was 18, but X itself was 20. Now let's focus on these angles. All right. What I need you to notice here, remember that the mid segment is parallel to the two bases. So that means that we actually have an angle relationship here between Y and 27 degrees and its corresponding angles. You could see with these two lines being parallel, but one's on the outside and one's on the inside, even though they have the same transversal. Because they're corresponding angles, we can actually set them equal to each other. So Y is actually equal to 27 degrees. All right, so that's how we would use these characteristics of a midsegment of a trapezoid.